Cellular injury, it's continuation with something called as cellular adaptation. After cellular adaptation, we should learn about cellular injury. It's the second part of this chapter. So cellular injury. So cellular injury, how it happens that if the cellular injury is slow and persistent stress, it can usually lead to atrophy. It can, if it's a fast stress, if the injury is very, if the stress is really fast, really it's a fast emboli in a blood vessel, it can lead to infarction. So it depends upon the severity of the stress, the injury can change. What is cellular injury? Well, if the cellular injury overcomes cell's ability to adapt, the cell gets injured. That's the cellular injury. What does cellular injury depends on? Again, the type of stress, the severity, type of cell it's being done on. For example, if it's done on a neuron, they are more metabolically active. So neurons can withstand hypoxia for 3 to 5 minutes, and skeleton cells can resist, hypoxia for very long time because they are metabolically less active, and neurons are metabolically more active, they need more oxygen. So stress, type of stress, severity, so this can change the dynamics of an injury. Other thing is, what are causes of hypoxia? Low O2 delivery to tissue. Hypo means low, oxia means oxygen. So what happens is that in hypoxia, you have low oxygen, leads to low ATP formation, leads to cell injury. So how it happens, we'll know about it, everything. So what causes of hypoxia? Number one cause is ischemia. Ischemia is just less blood flow, and this less blood flow can happen because of atherosclerosis, that is the arterial blockage of the blood. If your arteries are blocked, so it's atherosclerosis, one of the example. I'm just explaining you if the arteries are blocked. Another thing is can happen that venous is blocked. For example, this is the artery system and this is the venous system. Here's your cell. So here's the venous system is blocked. So what will happen is that here the venous system was blocked. So again, ischemia can happen, less blood flow, the flow of the blood was blocked, so venous blockage can happen. Other thing that can happen is called hypoxemia, which is partial atrial oxygen pressure is less than 60 millimeter of Hg. What's the whole story about this is that FiO2 is the environment pressure, okay, the oxygen pressure in the environment. Usually it leads to alveolar pressure. It is PA alveolar. Sorry, this P small a was arterial pressure, okay. So if the partial pressure of oxygen in your arteries is less than 60, it can lead to hypoxemia. So what happens, this FiO2 environmental pressure give rise to alveolar pressure in the body, and after this the oxygen goes to the arteries, so arterial partial pressure, and then it gives rise to the saturation of oxygen in the hemoglobin, so SaO2, we call this SaO2. So FiO2, P capital A, P small a, and SaO2. So PA alveolar pressure, if the if the partial pressure of carbon dioxide in the alveoli rises, the partial pressure of oxygen in the alveoli goes down, because the capacity, the oxygen carrying capacity of alveoli is staying the same, right? So you can either have carbon dioxide or you can have oxygen. So if it goes up, it goes down, and the vice versa is true as well. So low partial pressure of oxygen, so I hope you get the concept of this. Another thing is that low O2 carrying capacity, it means there's something wrong with this thing. What happens that it happens in anemia, it happens in carbon monoxide poisoning, it happens in megalobulimia. Okay, we'll talk about it. Nothing so tough. So what is shock? Let's talk about this. What is shock? What are its causes? Well, shock is a generalized decreased perfusion of vital organs. Okay, so you have less blood flow to the organ. It can occur by hypovolemia. It means less volume of the blood. It can happen by cardiogenic shock. It can happen by septic shock. It can happen by neurogenic shock. It can happen by anaphylactic shock. Okay, so shock is generalized, diffused, and these are like reasons. Okay, so cardiogenic reason, septic reason, neurogenic reason, and anaphylactic reason. You're having an anaphylactic hyper reactive reaction, so it can lead to less perfusion to the organs, so it can lead to shock. It's not an electric shock, it's a shock to your body because you're not getting the perfused blood flow to the organ. Another thing is called, what is Budd-Chiari syndrome? Well, the blockage of hepatic vein. I told you about venous blockage. So the blockage of hepatic vein can result to hepatic infarction. What is infarction? The death of the cell is infarction, aka Budd-Chiari syndrome. So hepatic vein is damaged, not damaged, it's just blocked. So most common cause of Budd-Chiari syndrome is polycythemia vera. It means your blood is really thick. So polycythemic vera is a disease in which there is too much RBC, which can lead to clot formation. Another cause is lupus, where you have ANA, that is autoantibodies for yourself. It can lead to clot formation, and it can lead to the venous blockage of your veins. So this is Budd-Chiari syndrome. What will partial arterial O2 and O2 saturation in anemia? So in anemia, you have problem with the O2 carrying capacity. Okay, so if you guys have some O2 carrying capacity problem, what happens is that the partial pressure of arterial, so arteries partial pressure is normal and O2 saturation will be normal. What will happen is that the number of RBCs, okay, will be less. So the pressure on each RBCs is normal. Okay, so each RBC will carry the same amount of oxygen, but the number of whole RBCs will go down because you have anemia. You're not making enough RBCs. So that's the whole idea of anemia. Okay, so when I told you guys this, it's low O2 carrying capacity, changes in saturation, I was wrong. I don't know why did I say it. So low O2 carrying capacity means something wrong with RBCs. Okay, because carrying capacity changes here. Okay, so what happens in anemia? You have less RBCs and total amount of oxygen will be less. What will be partial pressure of arterial pressure of arterial O2 and O2 sat? O2 sat means saturation in carbon dioxide poisoning, carbon monoxide, or any sort of poisoning. Okay, so what will happen is that this alveoli, okay, will be the same. Why will it be the same? Well, because it will be the same because alveolus are normal. Okay, they are not damaged. Okay, so the alveolar oxygen pressure will be same. So for example, this is your one alveoli. So when I say about alveolar pressure, I'm talking about the oxygen here staying here. So this is the pressure I'm talking about, right? And when I'm talking about arterial, it means this is an artery and the oxygen in the artery is. So I hope you understand the concept of partial pressure. So PaO2 will be the same. Why? Because alveolars are normal. And O2 saturation will reduce. Why the saturation will reduce? Because CO monoxide binds to hemoglobin 100 times more stronger than O2. So what happens is that the CO comes and replaces O2 on hemoglobin so that O2 cannot bind it and it just sits there. So that's the story about CO poisoning, monoxide poisoning. What are the signs and symptoms of monoxide poisoning? Well, one of the earliest signs is headache, and another classic representation is cherry red skin color, because the monoxide gives the color of cherry red skin. Okay, it binds really stronger, 100 times binds stronger than the oxygen. What is methemoglobinemia? So methemoglobinemia, normally iron, that is ferrous, in hemoglobin is +2 state. Okay, so +2 state can bind to O2. That's I remember. So O2 binds to +2. Now if this gets oxidized, if you give the iron a little bit oxidation, what happens that +2 jumps to +3. Now if it gets to +3, it cannot bind to oxygen because O2 binds with +2. So it cannot bind, and we are left with something called as methemoglobinemia. Okay, So, what will PaO2 and O2 saturation be in methemoglobinemia? Well, what will change is that PaO2, the arterial or partial pressure of oxygen, will be same, and the saturation will be changed because the hemoglobin now is in +3 state. Now it cannot bind to oxygen. So this changes. The O2 saturation of each RBC changes because the hemoglobin has changed. The PaO2 will remain the same. The partial pressure on the in the artery will stay the same. Okay, so that's the concept. What are the causes of methemoglobinemia? Well, there's something called oxidative stress. Oxidative stress means drugs like sulfur drugs, nitrate drugs, also seen in newborns physiologically because their machinery to reduce Fe to Fe2 isn't good. Okay, so methemoglobinemia, we see this a lot in newborns because their machinery to convert Fe3 plus into Fe2 plus is not really good. What are the signs of methemoglobinemia? Number one is cyanosis, the bluish color of the skin with chocolate colored blood. Okay, so that's the classic representation, cyanosis with chocolate colored blood. What is the treatment for methemoglobinemia? Well, math stands for meth, and I love math. I don't love math, I mean, math, MATH, not METH. So, methemoglobinemia, number one treatment, IV methylene blue. It generates something called that moderators that changes that Fe3 plus into Fe2 plus. So, IV methylene blue. What are the consequences of low ATP? Well, you know that low ATP means hypoxia, right? And hypoxia means low ATP. What happens is that in hypoxia, you have low ATP, right? So, number one thing is lactic acidosis because there are a lot of glucolysis, a lot of lysis of glucose is happening, a lot of glucose is breaking down. So, acidosis. So due to aerobic, it changes into anaerobic catalases. We don't want to know this. We'll just talk about gluco. The number one thing is acidosis. Your environment of the cell will change into acidic environment, and you know no anabolism can happen in this acidic environment. So lactic acidosis will happen. Another thing is disrupted Na pumps. If these Na pumps are disrupted, means 3Na and 2K pumps are not working, so 3Na will not go out, 2K will not come in. So what will happen is that a lot of Na will start to accumulate in the cell, and it will lead to a lot of edema because because water follows Na. So result in Na accumulation, resulting water accumulation, called edema. Okay. Other thing is disrupted Ca pumps. It's really dangerous for the cell because if Ca cannot go out, because cells don't want to carry a lot of calcium intracellularly, because calcium is a signaling molecule and it can signal a lot of things. It can signal cell death, it can signal apoptosis, it can signal a lot of pathways which cell doesn't want. So cell usually stores these calcium in reticulums. Okay, cell usually stores them in a box. So Ca pump results in Ca accumulation, random enzyme activation because it's a signaling molecule. It activates a lot of enzymes in the cytosol. So cytosol keeps calcium low as calcium is an enzyme activator. Cool. What are reversible finding in low ATP? The reversible finding hallmark is cell swelling, because if your cell is swelling, it means there is an Na accumulation, right? If there is an Na accumulation, we can reverse that. We can kick the Na out, and then cell can be normal. So if cellular swelling is reversible, loss of microvilli, membrane blebbing, it means the membrane bleb like this. Membrane blebbing as it pulls away from cytoskeleton. Swelling of RER. Swelling of RER is rough endoplasmic reticulum, and ribosome fall off because ribosomes are weakly adhere to RER. So if ribosomes fall off, it means less protein synthesis. Less protein synthesis, it means cytoskeleton gets messed up, and so that's how it works. What are irreversible? Well, irreversible is if there is calcium accumulation in the body, in the cell body. So what are irreversible? It cannot change. Hallmark is membrane damage. So this is the membrane, right? If it's damaged, it means something from cytosol will leak outside of the cell into the plasma, right? So hallmark damage is membrane damage, results in cell death. So cellular enzymes leak out. For example, liver enzymes, ALP, AST, in hepatitis, they leak out into serum. In cardiac, MI in myocardial infarction, cardiac enzymes like troponin C, it leaks out and its intracellular calcium level increases. Okay, so intracellular calcium levels means calcium inside the cell increases, and if this increases, so this in itself is a enzyme activator calcium. So imagine if it's added with lysosome. If it's added with lysosome, it will be very bad for the cell. I will tell you how. So there's something called a cytochrome C. Well, cytochrome C is formed from the mitochondria, right? For example, this is the cell, this is your mitochondria, this is cytochrome C. So this is inside the mitochondrial membrane, not membrane, mitochondria. And if it leaks out, what happens that from mitochondria it leaks out to cytosol and activates something called apoptosis. So this cytochrome C tells the cell to die. This is apoptosis. Apoptosis is physiological way of cell dying. It's not murder, it's physiological. Lysosomes, it means lysosome enzymes will leak out and digest the cell. So lysosomes are just very hungry enzymes. They go and eat the cell from itself. So calcium in cytosol activates them. Okay, so lysosomes are activated by calcium. So that's why I wrote this. Intracellular calcium rises, and with the help of lysosome, it can be very bad. The lysosome can eat itself. So electron transport chain is present in the inner mitochondrial membrane. So this was the cell, this was the mitochondria. So here, this is the mitochondria. If this mitochondrial, membrane is damaged, your cell is cooked. You are cooked if mitochondria is damaged, right? Because you cannot reversibly repair your mitochondria. So that's the whole concept of cellular injury. That's how the injury. Remember that hypoxia, ischemia, hypoxemia, these things are very important. Another thing to remember is this methemoglobinemia. We give methylene blue, the chocolate colored blood, for methemoglobinemia. What is methemoglobinemia? Why it happens? +2 state jumps to +3. Newborns cannot change this +3 to +2, so they suffer from this. Drugs called sulfur drugs and nitrate drugs, they put something called oxidative stress on it. So that's the whole concept. Another thing is cherry red skin seen in cyanos, seen in monoxide poisoning, carbon monoxide poisoning. Headache seen because of cephalohypoxemia. Cephalo means brain, hypoxemia is hypoxemia. Hypoxemia leads to hypoxia. Okay, what else? I think we are done for this chapter.